All right, here we go. 9.2, day 3, rows, curves, and that is pronounced Lemniscates. We'll do Lemniscates later. This is going to be a rose curve, and I know for sure it's a rose curve because there's no plus or minus. It's R equals with a whole bunch of stuff multiplied together. Actually, I'm getting a little bit ahead of myself, though. I want to give you guys 4 tips. I'm just going to make a little graphic organizer because it's key to make this stuff easy. Tip number 1, cosine is always on the x-axis. It's not really an x-axis. It's on the horizontal axis. We'll call it x-axis. Number 2, sine, you got to work for sine. Sine, you're going to have to take 90 degrees and divide it by n, and that's where it's going to start. And I know you don't know what n is, but you'll know it. All right, next one. Let's talk a little more about n. If n is odd, you leave it alone. Last one. If n is even, you double it. And what is n? Y'all, is the number stuck next to the theta sign. So in our little example right here, what number is stuck next to the theta sign? 2. 2 is n. All right, so here's how this stuff plays out. We're drawing some flowers. We have to know how long our flowers are, so we're always going to find the length. We're always going to find how many petals are in our flowers. And we want everything to be symmetrical. So we have to do our spacing where they are all evenly spaced apart on the graph. Okay, so the length of the petals is the first number. So the length of all of our petals are going to be 4 units. The petals come from, remember this is called n, but if n is even, which it is, it's 2, we're going to double that number. So we're going to have 4 petals. So whatever number is next to theta, if it's even, you always double it. All right, so this is a circular graph. There's 360 degrees. We want it spaced out evenly. So to find our spacing, this is going to be 360 divided by our total petals. So each petal is going to be 90 degrees apart from each other. All right, so here's how we get started. Everything's always centered at the pole on this. So I have a length of 4 units, and remember it's cosine, and cosine starts on the horizontal axis. So let's count 4 places, and we're going to have a petal go through that point right there. And then everything else is 90 degrees apart. So 0 degrees plus 90 is right here. 90 degrees plus 90 degrees is 180. So this very first graph that we're going to practice, all the petals are going to be on the axes. That's all you need. So just draw your petals the best you can. Try to make them symmetrical. Don't get obsessive like your teacher. That's it. All right, so we just graphed a rose curve with 4 petals. And y'all, how did I know it was a rose curve? There's no plus or minus. It's all multiplied together. And guys, just a heads up, y'all see those parentheses right there? They're so not necessary. You may very well see something that looks like this. It means the same thing. Since everything's multiplied together, the parentheses mean nothing. But they're there. All right, we're going to do another cosine one. So for this, let me zoom in just a little bit. All right, so here we go. Same process, length, petals, spacing. Length, petals, spacing. All right, so the length is going to be 3. The petals are going to be 8. And the spacing is going to be 360 divided by 8. Y'all, what's half of 360? Do y'all know half of 360? 180, yes. All right, so 360 over 8 is 180 over 4, which is 90 over 2. So what does that simplify to? Yeah, they're all going to be 45 degrees apart. All right, so here we go. It's cosine, so let's go 3 places away. And then 45 degrees from this, guys, remember the 45 degrees are the diagonals. And y'all can graph a little dotted line, you know, if you want to. But if you can kind of visualize where 45 degrees is, you don't have to draw the dashed line. So 45 more degrees. 45 more degrees. So every 45 degree increment is going to be your pi over 4 and your major axis. All right, draw your petals. All right, so that's that one. Any questions on that? All right, so look, I'm gonna zoom out for a moment. We're about to do sine, and y'all are gonna have to remember you have an extra step on sine. It's easy, but you're gonna have to remember that you have that extra step. All right, so oh my goodness, it starts on sine. Okay, let me knock out this first step. To figure out where it starts, y'all, it's never going to start on the x-axis. So sine is going to be 90 divided by the n value. The n value is 3. 90 divided by 3 is 30 degrees. That's where it starts. It's going to start on the 30-degree line. And y'all remember, each one of these lines are pi over 6, but pi over 6 is 30 degrees. So this is 3, 6, 9, 12, 150, 180, 210, all the way around. You can just count by 3s when you're dealing with degrees. All right, everything else is the same. Length, petals, spacing. Length is 4. Petals are 3 because it's odd. Don't double your odds. And then spacing, yep, 360 divided by 3 is 120. Cool. All right, here we go. So look, 30 degrees, length of 4. 1, 2, 3, 4. Y'all, here's where your first one is. And you're just going to count by 3s until you land on 12. That's where the next one starts. So here's 3, 6, 9, 12. 3, 6, 9, 12. So there's your petals. Another sine and another cosine. All right, sine. So again, you're going to take 90 degrees. You're going to cut it by the end value. So these are going to start on the 45s, the diagonals. My length is 2. Y'all, how many petals are on this? Yes, great job. And 360 divided by 4 is going to be 90 degrees. That's the spacing. All right, that's it. So your 45 is on your diagonals. And guys, if they're all 90 degrees apart, all of your petals are going to be on the diagonals. So plus 90 is going to put it here. Plus 90 is here. And plus 90 is here. All right, draw your petals. All right, so that's number 5. So for the next one, y'all, these are the only graphs that have x squared. I'm sorry, r squared. And anything that's r squared is called a lemniscate, and they're so easy. You don't have to find anything. All you got to do is take the square root of the a value, because if r is squared, then a is squared. And then that's going to be the length of the petal, and there's always only 2 petals. And it either starts on the x-axis or it starts on the diagonal, never anything different. So look, over here, 1, 2, 3, because that's the root of that. And lemniscates are like reflections. They look like infinity symbols. So I went 3 that way. I'm going to go 3 this way. And this is what it looks like. And number 7 is going to be the exact same thing. You're just going to start on the diagonal. So for problem 7, square root of 16 is 4. It's going to be a 4 length. So 1, 2, 3, 4. And then go 4 places in the opposite direction. 1, 2, 3, 4. And that's it. Those are called lemniscates. This is how you write it. Lemniscates is how you say it. And how am I going to know when I see a lemniscate? So easy. It is the only one that's r squared. That's it. So look, down here, this is going to start on the 45, 2 places. So again, your sines always start on the 45. Your cosine doesn't. Starts on the horizontal axis. And that's it. Do y'all have any